With everything you've learned so far, it's time to move towards a process that's called debugging. The term literally comes from taking bugs out of relays, which made up the logical units of early computers, and it kind of stuck around. So you had this great idea that you laid out in a flow chart and you thought it out very well. You decided on how to write the code. You wrote the code, you run it, and it doesn't work. Ideally, you don't try to write all the code all at once. Come to the first box in your flow chart. You wrote the code for that and it doesn't work. How do you go about fixing it? Because it's ultimately you who has to work on this and get it done. I want to review the high-level software development cycle. Right in the beginning is design. I just mentioned it. The flow charting, the thinking about which components do what and how they work together. And you start coding some of those things up and you test them. You try to make sure that they do things as expected, and usually they don't. And that's when the debugging comes in. And then you go back to 1, 2, and 3 and do everything until that component is working and you move on to the next one. This is really common to all programming strategies, independent of how involved each stage is, right? You can do that for a small function that does one thing. The design stage is kind of thinking about it, what should go in the function, what should come out, does the function do the things internally. You write them up, you test them, and the function returns aren't what they're supposed to be, or you're not even getting a return because the code crashes. You have to debug. And that scales up to all the elements that make up an operating system or distributed system. Debugging is the art of finding and fixing mistakes in computer programs. To be successful, you need insight, creativity, logic, and determination. The emphasis here is on art because that's really what it is. You have an almost infinite number of possibilities of mistakes that you could have incorporated into your code. And now it is up to you to creatively and quickly find the problems that you may have caused. Logic plays an important role. It is oftentimes a good idea to try to isolate the areas of code where the problem occurs. Logic helps with that. Determination is incredibly important because sometimes you will just not find the mistake unless you really hunt it down and you keep at it. It is a necessary part of programming and code development. It is just as important as the initial design phases, and it is often requiring much more of you to fix things than to initially write them up and mess things up. Brian Kernighan stated that debugging is twice as hard as writing the code in the first place. Therefore, if you write the code as cleverly as possible, you are, by definition, not smart enough to debug it. The first sentence here kind of echoes what I just said. It is a lot harder than the initial writing of the code. When you initially write the code, you live under the illusion that all of your assumptions are right and that what you just wrote will actually run and execute correctly. And then you get the reality check when you try to run that code and it doesn't work. And you were really clever in setting up the code. And now you've got to defeat your own intellect and try to figure out where the errors are. So the lesson here is to write code that does what it's supposed to do, but don't try to have the first iteration be the most efficient that you can come up with, because the debugging is only going to get harder. So there are some truths about bugs and debugging. First, bugs are static. They won't run away. They are somewhere in the code. You made an assumption about something and it doesn't work that way. So you really have to question your assumptions and read through the code without being really tethered to your ideas on how things should work. The fact is, they don't work the way you assumed. So, got to fix it. More often than not, the problem is really something very simple. Could be an off by one error. We talked about how some programming languages start counting at 0, others start counting at 1. So, your indexing in some arrays might be wrong, or you're calling the wrong function, or for some reason, the user isn't giving you the input that they're supposed to give. So start with simple solutions first. You were the one who created the code, so you made that bug. So next point here is that it's generally your fault and not the others. It is a really good way to learn being self-critical. Good luck with that. But it is an uncomfortable truth that we all have to face, that we do make mistakes, and programming is the best way to face them. Subset of the mistakes that we make. And it is not the right choice to say, oh, this library is wrong, because in reality, a dozen people have worked on that library, hundreds or thousands of people have been using it successfully. Probability is not 0 that you are the first one to find a mistake, but the probability is pretty low that that is the case. And even if you were to find something that doesn't work from code of others that you're using, you want to make sure that it is indeed not your problem. And having something written the first time is usually a great way to have misunderstood or wrongly used the tool rather than the tool doing the wrong thing. You got to be critical on what you really mean when you're implementing your logic or other operations. Here's an example. Did you really mean less than or less or equal than, greater than or greater and equal than? That kind of falls a little bit into the category of off by one errors. There's no need to panic. It kind of goes back. The bugs are just going to stay there. That is fine. You'll start panicking if there's a deadline that's looming. Then you probably started working on this too late and not giving yourself enough buffer to finish high quality work on time. The panic isn't going to help. All it's going to do is you'll just kind of randomly hunt things down that may or may not pan out. You've got to be systematic, right? Like make informed decisions on like, where does the code break? Up to where in my code have I made it? That's a good indicator that something's going wrong in there. Now, then you have to figure out, is the bug or the error actually in that line of code that is breaking? Or does that line of code work on a variable, for instance, that doesn't have the right information that happened somewhere before? What often helps is sleep, or just kind of walking away from the problem and coming back later. The human mind has an incredible capacity to kind of work on problems in the background. Sometimes it's just good to come back with fresh eyes and have abandoned some of the assumptions that went into the debugging in the previous session. So there are some simple strategies that you can follow. One is echoing, where you simply place print or echo statements at useful points in the program, function entry or exit. And what you can do with echoing is return to the screen the contents of variables, or you can simply say, I made it to this point. I'm done with this function. I generated these values. You can dynamically inspect various variables. Works quite well for kind of the scale of programs that we are working with here, for sure, but it really works for any kind of program. And it really isn't anything more than a print statement and some carefully selected variables or values of variables and some information of where you are on the program. There are other more involved techniques such as unit testing. Here you write calls to a particular function, hand it artificial values, and you automate this to test with every change of the code whether this function, given those values, still does the same thing that you assumed it would. Right. So that's a good way to say you wrote a function that converts latitude and longitude values to some distance. Now you have a latitude and a longitude, latitude and a longitude. You want to calculate the great circle distance between those 2 points. You implemented a function that does that. What you can do is you can test it by using latitude, longitude A, latitude, longitude B, and you know that the distance between those 2 points is 25.6 kilometers. So a unit test would then check that the output of that great circle distance function is always 22.6 kilometers for these 2 points. You can do that for all of your functions in your code to ensure that certain functionality stays the same. And when you manipulate your code, you run those tests, and if something breaks, you know that it was due to what you've just done. Exception handling is, kind of an assistant to debugging in high-level languages. There are these cases where you're trying something, right? It was the try and except in Python. You're trying some block of code, and if there's something that's going wrong in this, the code isn't going to stop running, but it tells you that something went wrong in this block of code. And more often than not, that is actually going to result in some later failure that needs to be dealt with. Sometimes handling these exceptions is perfectly fine, and you do not want the code to break. You expect these exceptions, and then you just keep it running by handling them appropriately. Online debuggers, for our purposes, they're really not necessary. They are useful if you want to step through code or you have memory problems in your code. But what they allow is they execute the code, and at each line, you can inspect all of the variable values, where you are in the code, etc. It's fairly sophisticated and helps a lot for lower level languages. Version control is not really a debugging technique, but it helps to have a tool that keeps track of the changes that you make. So you basically, GitHub is one of these systems that employs a tool called Git. That's the latest in a long line of different kinds of version control systems. In principle, how it works is you have written your code, you hand it to the version control, you make local changes, and then you hand the new version to the version control, and it notices what things have changed, and you'll be able to roll back a broken version of software that is due to your changes. Maybe you've made a lot of them at once, to a version that is still working, and then you can isolate the code that causes the bug by simply comparing those versions and see where you made changes between those two versions, and focus your debugging, perhaps with echoing, on those areas of the code. So a word about debugging styles, echoing versus online debuggers. Here again, Brian Kernighan and Rob Pike, The Practice of Programming, a quote: "We find stepping through a program less productive than thinking harder and adding output statements and self-checking code at critical places. Clicking over statements takes longer than scanning the output of judiciously placed displays. it takes less time to decide where to put print statements than to single step to the critical section of code, even assuming we know where that is. More important, debugging statements stay with the program, debugging sessions are transient. The two big schools of thought may be that you add these print statements throughout your code or you use an online debugger. I think this quote makes pretty clear where I am on this. I certainly like output statements and having self-checking code rather than running through debugging sessions with an online debugger where you kind of click through your code and look at variables. And the key thing here really is the last point. Those print statements, they stay in the program. You might even be able to turn them off and on if you do it a little cleverly. That your code can be run in debug mode versus in production mode. So the echoing style is at the simplest. You add print or echo statements where necessary, and more sophisticated, kind of the idea that I hinted to in my previous statement, you could have a function that displays text only or that's only executed if there's some kind of global debug flag set. That could be a simple variable that is set on the command line. We'll talk about how to hand things into the program via command line in a little bit, but simply have a function that is print debug and that gets some text, and in there is an if statement that says if the debug flag is set to true, then print the text that is being given, otherwise don't. You can call this function whenever is necessary, entry or exit of functions, display variable values before or after critical operations to follow the program flow, and you can turn debug off when everything works. An important thing to remember, though, is that you do not want to overwhelm yourself with printed output at every stage of your code, right? The key component in here is judiciously placed displays, right? If you spam yourself with output from your program, you are just going to have as hard a time to find where things are going wrong as if you didn't return anything. So keep that in mind. Unit testing is at the simplest writing a script that calls your functions with artificial values and compares results to expected outcome. The example was the great circle distance, right? We expect a certain distance between the points A and B. If that distance isn't correct, something is going wrong. Execute these unit tests whenever the code changes or when code changes are made. It helps us to detect errors due to changes in functions immediately because you just made the change, and it's possible for any language. There are fancy frameworks for some languages.